table. Per table, I apologize. I didn't make myself clear. Those are the reference charts, one per table. I made those this morning. And you should be taking the information from the board right now, quickly. And right here where it says, H there. Let me just briefly explain to you what we're going to do. Look at your data sheet right now. You can stop writing for a moment and look at your data sheets. The data sheet says objective students will sample two area bayous. We did that last week, Brays Bayou and Buffalo. Today we will determine the concentration of various minerals found in this water using chemical methods. Now, originally, we were going to do instrumental methods. We already know we're doing something different today. Today, we call this benchtop wet chemistry, where the analyst comes in and all of the analyses are done by you, your hands on, with your naked eye. Mr. James, please give everybody a pair of gloves. Remember something else that you learned last week. Buck time. Where are my Molucks? Wait a minute, I've got them. Julie, I got them. Raise your hand and tell me this. What chemical did I add to the samples last week to keep the bugs from eating the toxins? Julie? Acid. Acid, very good. For 2 bucks, what is the name of that acid? Who remembers? Check your notes, Go back into your memory picture. Don't put your gloves on yet. What's the name of that acid? Anybody remember? Who said it? It's okay to look in your notes. Good notes always mean I can use them. Do you have it? Say it for me. HCl. Students, repeat after me. HCl. HCl. Very good. $1 for you. $2 for you. That is hydrochloric acid. Now, Isaac here. The water samples originally had a pH of 7, but the hydrochloric acid was at a pH of 4. So the pH has now changed slightly. Should be a little lower. What we're going to do this morning, we don't know what is in these 4 samples. Now, I want everyone that are at the tables with your back to me to kind of turn this way so that I can show you a couple things up front. Kayla, turn this way, sweetheart. Now, the red tape is sample A. On the board, you will find that this is the description of those samples. It comes from Brays Shallow, where we skimmed the surface and took a top sample. Now, yes, these samples are not divided by what group you're in. They're for all of us. So the way it will begin is this data sheet, please, data sheets up and look at them with me as you're going to use what we call a test strip. And that test strip has 5 different tests on it, all in one. Now, students, when you use this test strip, you will hold it from the end where there aren't any of the color indicators, and you will immerse it into the sample. Now, why are you wearing gloves? And why is it very important to be very careful? Remember, hydrochloric acid is a caustic acid. It will burn. Therefore, when you put your test strip in there, don't let that sample pop on you. And we will have strips of paper on your table available for you to put these on when you finish. Group 4, remember we made the simulated water? What was the name of that chemical in that water? $5. $5. Oh, Epsom salt. Okay, 5 for you. Give me the chemical name. That's a commercial name. He just said, Julie. Give it up. Give me some of that. Give me some of that. Come on, girlfriend. All right.
spaced out. Quickly, sorry.
She said it doesn't matter.
I think we have to, like
Submerge the whole thing. Swirl. Alright. Yeah.
you say it's about the last one.
Yeah, and then 120, the journal hardness. And then this is 240.
240.
And then wait 30 seconds. For those to.
Okay, right here, I would say 120. So 120, and the last one, general hardness, is a true 180. And that's all you do. And then pass the sample to the next student. Okay? Right here on your paper, please write temperature of water and take your thermometer and test the temperature of the water sample. They're all going to be about the same because they're all in the same environment. See them, 80.
Okay.
What do you have on the nice one?
them? I thought she was just taking them.
Is that what it says on the chart? Oh. Okay, cool. 0.5. What about nitrate? I mean pH. 7.5. What about hardness? Carbonate. It's interesting. Between
What is it? I think it's right.
and what about general hardness?
The 20?
Yeah.
Okay.
No, it's before
No,
this
that's
one, so it's
The 18?
So the 200
the
is
19
darker.
before.
So far, does anybody have a temperature reading? What do you get? 19 degrees what? Okay, no, you don't think. Go get that thermometer and read it. Let me see for sure. No, we have to know. Scientists are very exact.
Is that the line right there?
Yes, sir. Hold your hand up here so that your hand doesn't warm it up. Put that there. Okay, look. Now turn it this way. Now, come here. I need everybody just for 30 seconds to come to this table. I have to show you something. This is a great example. Now, come on, y'all. Come around here. Well, this one might not have the same dimensions. It does.
Oh,
Come around.
it goes to 100 right over here, and then it goes to 20.
Right, sweetheart. Let me explain. That's why I have all of you here. This thermometer and this one does not, depending on which one you have. But most of you all have two scales. You have what? Centigrade, which is Celsius, and Fahrenheit. On this side is your C value, your Celsius, and the other side is Fahrenheit. If you all, eyes down here, if you look at this sample, and I want to take this white piece of paper and you hold it right here when you can't see for sure. That's, the 20 is there, 19, and it's right under 19, so we can't read in between, so we will call it, if it's in the middle, we'll call it 18. 18.5, 18. Let's see what it says on the other side. Degrees C is 18, but degrees F, I'm looking at, if there are 5 little marks between 60 and 70, what is the value of each mark? Very good. So this is 60, that's $2 for you. This is 66 degrees F, but it's 18.5 degrees C. So everyone record that value down.